So here's why scientists want a good quantum computer. In October 2022, US President Joe Biden visited a quantum computer in New York. The gorgeous contraption had been built by the high-tech company IBM.
Computers is something called qubits, or quantum bits.
Like a futuristic sculpture, it had complex curves of gold tubes and wires. Photos of the visit show Biden studying the machinery. But anyone looking at those photos might wonder, how is this thing a computer? The temperature inside the machine, called IBM Quantum System 1, is almost unfathomably cold. It's a fraction of a degree above absolute zero, which is the coldest possible temperature. IBM has installed Quantum System 1 machines in many places around the world. Some of them are encased in the same kind of glass used to protect Leonardo da Vinci's Mona Lisa. At absolute zero, everything stops moving, and quantum computing can take place only at a silver of a fraction of a degree above absolute zero. The golden sculpture looking part of the quantum system 1 is what keeps the computing part so cold. Anytime you Google quantum computer, the picture that comes up are these big beautiful golden chandelier, said Corbin Tillman-Dick. He founded Maybell Quantum Industry in Denver. He spoke there about these quantum machines last February. It was at the annual meeting of the American Association for the Advancement of Science. Looking at those photos, I get kind of amused, he said. They think they are standing next to a quantum computer, but really that chandelier is the fridge. The part that solves computing problems sits on a piece of silicon at the bottom of the contraption. It's so small it could fit in your hand. Tillman-Dick should know. He designs and builds ways to keep those quantum devices cold. He jokes that he is a high-tech refrigerator salesman. Tech companies including IBM, Microsoft, Google and others are racing to build the best quantum computer. Why? Their scientists think these devices will soon be able to complete tasks and solve problems faster than any number cruncher today. Quantum computing will likely to be able to tackle problems that today's machine can't. Quantum computers are not able to do that yet, but they are getting close. Kyla Lee is a biologist by training who now works on building a global quantum computing community at IBM in NC. It's an exciting time to be in the field. She says, there is so much opportunity. What's the big deal? We have already gotten some glimpse that quantum computers might one day outperform normal or classical computer. Take Sycamore. Last December, Google reported that Sycamore, it's a quantum system, had quickly completed a difficult task related to how a random system runs. It requires only 6 seconds. The same task would likely require years on the world's fastest traditional computer. That's a supercomputer known as Frontier. It's housed at the Oak Ridge National Laboratory in Tennessee. Google's test put Sycamore through some early paces. The problem it solved in 6 seconds showed off the machine's number crunching power. But that computing task itself isn't very useful for solving the world's problem. No quantum computer worked well enough yet to start solving big important challenges. What's got experts excited is what this new generation of computer might do, and soon. Some predict quantum machines will solve complex problems related to climate change. Quantum computer might also identify better battery designs. They might find new ways to generate renewable energy or make energy system more efficient. Quantum computers could also help solve what seems like old school problems but really aren't. Take figuring out how to move goods around the world. This is remarkably hard to optimize because it involves trucks, trains, ships and planes moving across different environments. Shipping companies can save time, money and energy by using the best routes, and quantum computers may help find those paths. Part of Lee's job at IBM is to help people learn what quantum computer will and won't be able to do. She also helps businesses and researchers get started in learning how to use such a device. Even though it's computer, a quantum computer is unlike the technology behind laptop, phones and other electronics. Some new article, Lee says, oversells the possibilities. It's not just a faster computer, she says. It's not going to solve every problem. One big challenge is to find the problem that quantum computer will solve faster. In some cases, a quantum computer may not offer an advantage if there is no quantum algorithm or recipe for solving a problem. And some problems solved by quantum algorithm can still be solved at fast by classical computer. Quantum computers also may not be good at tasks that require a lot of memory, because they can't yet store much data. They also may not speed up tasks that focus on multiplying or adding numbers. because classical computers already do that well. But this emerging computer should excel at a certain types of problem. Lee says, knowing how dependent on knowing how quantum computer work. Quantum weirdness. The science that led to quantum computing goes back to hundreds of years. It started by physicists who wanted to know more about the behavior of light. In the 17th century, Isaac Newton argued that light was made up of tiny particles, but experiments in the 18th and 19th century showed that light travels like a wave. By 1900, most scientists thought light was made up of waves. In fact, both team wave and team particle turned out to be right and wrong. In 1905, physicist Einstein put the pieces together. He proposed that light traveled like a wave, but it could be observed like a particle. Another physicist later introduced the term photon for this type of particle. Surprising discoveries about photons in the early 1900s paved the way for the quantum computer. Lee says key among these was the idea of superposition. The principle of superposition says that thanks to its wave-like nature, a photon can exist in more than one state at one time. Here is the word state describe some physical property of the particle such as its location. So the rule of superposition says that a photon can be in more than one place at a time. We will never actually see a photon in two states, such as two places at once. As soon as you look at a photon, it only has one location. Physicists explains this by saying it collapses into one state. But while a photon remains unobserved, superposition allows it to exist in multiple states at once. Physicists have since discovered that photons are not the only particle that can act like waves. Electrons, atoms, and even molecules can show wave-like behavior. So they too follow the rule of superposition. It's just harder to see this weird quantum effect as you look bigger or the warmer temperature. If that sounds confusing to you, you are in a good company. I think I can safely say no one understands quantum mechanics, said by the Richard Feynman, said in his lecture he gave in 1964, and he should know. He is the physicist who came up with the idea of harness the weirdness of superposition in a computer. Even after scientists and engineers like Feynman had the idea of quantum computer, it took them decades to build such a machine. Think of it, Lee says, a new model of computation, bits, qubits, and entanglement. A normal computer stores and processes information using bits. A bit is a sort of switch that can be one or two states, on or off. This can be described as the bit having a value of 1 or 0. Each bit must be one state or the other at any given time. If you are seeing this or reading this on the screen, then every letter, number and punctuation mark you see is represented inside your digital device by bits. It requires about 5 bits to represent a letter or a number inside a computer. A device called transistor acts as a bit. Modern computer can hold hundreds of billions of bits. Quantum computers are different. Instead of bits, quantum machines store and process data using qubits. That sorts for quantum bit. Qubits can be made from any quantum particle or molecule that can exist in superposition of states. Unlike a bit, a qubit isn't limited just being on or off. Because of a superposition, it has some probability of being and some probability of being off at any given time. It doesn't settle into one of those states until someone measures it. Then it collapses into a single state just like a photon does when someone observed it. The combination of all of these collapsed qubits reveals the answer to the problem. That's what gives up the big speech, says Dan Gauthier. He is a physicist at Ohio State University in Columbus. His research focuses on how to use quantum technology in new tools. Because they might be in multiple states at once, qubits can process data faster than classical bits. Gauthier says, imagine you wanted to find your way through a maze. Using a classical computer is likely trying to each position path one at a time. A quantum computer, on the other hand, acts more as a mist that can float through walls, hover over the ways through the maze and condense into the correct path. A bunch of connected qubits can pack a lot of computing power. Say you have a quantum computer and an ordinary computer that can store and compute at the same amount of information. If you add just one qubit to the quantum computer, your ordinary computer will now need twice as much memory of the store to the same information as the quantum one. It will require twice as much time to compute the same problem too. Quantum computer may also get a boost from another strange feature of physics. It's called entanglement. Physicists predicted the special kind of connections between photons in the 1930s. If two photons are entangled, each loses its individuality. The two now shares a single set of properties. If scientists measure the properties of one particle, they automatically know those same properties of the other particle. The oddest part of the entanglement, if you entangle two particles and take them far away from each other, they remain entangled. This has been proven in lab experiments. Albert Einstein famously called this spooky action at a distance. Why? Because it seems like the particles somehow share information instantly and nothing, not even information, is supposed to travel faster than the speed of light. how entanglement works is still a physics mystery, but scientists have found ways to entangle photons. They have found ways to entangle atoms too. In December 2023, physicists at Princeton University even showed how to entangle molecules made up of many atoms. Entanglement could be useful for quantum computers, but errors are easier to find and correct in qubits with entangled states. Scientists are still trying to find the best ways to build qubits and to put them together. The challenge, explains Gauthier, is working with such small things. Superposition and entanglement can only be observed at tiny scales and very cold temperature. Quantum mechanics has different rules, he says, about how we make a larger system from a bunch of small quantum entities. Here's one example of a problem that a quantum computer might solve. Imagine your math teacher gives you two very large prime numbers and asks you to multiply them together. Remember that a prime number is divisible only by itself and 1. You can probably do that pretty easily, especially with a calculator. Now imagine you have given the same problem in reverse. Your teacher gives you a very large number and asks you to find two prime number factors that when multiplied together will give you that big number. It's more difficult. You could start by trying to divide the large number by prime number. Moving up the list number by number, divide by 2, then 3, then 5, then 7 and so on. But a calculator won't help you much. Neither will a regular computer. Even with a good algorithm, this task becomes very hard, very fast. Finding factors for 250-digit number would require thousands of years for an ordinary computer. Not so for a quantum computer. Because of quantum superposition, this device could more quickly rule out wrong solutions and find the right ones. In 1994, mathematician Peter Shaw described a quantum algorithm for how to do it. Mathematicians think Shaw's algorithm offers a speed up because of the entanglement. A powerful enough quantum computer could identify those factors quickly. It can evaluate all solutions at once, explains Gauthier. The ability to find prime factor of super large numbers may not sound useful, but it could actually pose a privacy risk to a lot of sensitive information sent over to the internet. That may include financial or health record. When data is sent online is encrypted or hidden from hackers using an algorithm. One of the most powerful algorithms for encryption involves multiplying large prime numbers. In order to make sense of encrypted data, the intent recipient has to know those two numbers. They act as a sort of key for unlocking the message. Onlookers may be able to see the encrypted message, but to make sense of, they need to know those two prime factors. And since finding those factors is a hard problem for any computer today, no hacker should be able to find it the key. With Shaw's algorithm, a quantum computer could then a hacker be unmask the encrypted data. This makes computer security experts nervous. So computer scientists are on the hunt for quantum safe ways to keep our data protected. Lee at IBM points out that quantum computer will be able to solve other real-world complex problems too. They might be used to find new machines or study to financial system like the stock market or analyze the chemical reaction or even help scientists better understand quantum physics. Plus, remember the problem of finding the most efficient route for transporting goods. Using qubits, a quantum computer could quickly find routes that were cheaper, faster or more energy efficient, or that had a smaller carbon footprint. Or it could find a better mashup of all of this. What's stopping the quantum computing revolution? Right now, all of this application remains just possibilities. They can't be calculated yet, at least not in the reasonable amount of time. Quantum computers also don't yet have enough qubits or enough accuracy to factor enormous prime number, so they don't yet pose risk of encrypted data. In fact, today's qubits are prone to error. That's because they are susceptible to noise. Noise can be anything that interferes with the superposition, Wi-Fi signals, for instance, or temperature. Noise accept the information that's stored or computed in quantum computer. A large part of quantum computer researcher focuses on the error reduction. This can be done by changing the design quantum computing chips, improving software, or better harnessing entanglement. We are still figuring out what a good qubit looks like and how do they talk to each other, says Leo. Companies are racing to build bigger, better quantum computer. In October 2023, a US company called Atom Computing unveiled the first one to have more than 1,000 qubits. IBM has also since built 1,000 qubit machines. The latest version of Google's Sycamore system has only 70 qubits, but they produce few errors. Researchers are excited by the fast progress and the potential of this system, but quantum computing needs some time and test before they'll be truly useful. If you ask me when we will have a real playbook, I have no idea. Gauthier says, I'm always amazed at how quickly things are progressing, but I'm still unwilling to put a real-time scale on it.